Chapter 13, Simulation Modeling. We're going to look at what is called Monte Carlo simulation. So we'll be applying queuing theory kind of concepts. We skipped the queuing theory chapter, but that's not necessary for simulation topics. And the chapter outline is we start with a general discussion about simulation and what is Monte Carlo simulation, and then look at few examples. Textbook uses a very rudimentary procedure of looking up the random number table. So, but as we have done in the past, I'm going to use Excel, which allows you to model more realistic situations and be able to replicate the simulation modeling, which is what the most important benefit of the simulation modeling is, quite easily. Okay. Okay, and as part of introduction, what is simulation? Simulation is, at least in quantitative modeling sense, it is one of the most popular methods because it is fairly easy, and with the available technology and power of the computers, it is very easy to set up a simulation model and run and get some really useful and insightful results. But what is simulation in general? Simulation, it can be physical simulation. Oftentimes, aeroplane manufacturing, they build wind tunnels and use physical models to replicate what the actual conditions would be and observe. Okay, so that would be a simulation of reality, okay, using physical models. Okay, what we're going to be doing is simulating the reality in terms of mathematical models or Excel models. And simulation in general can be viewed as two broad categories of simulation. One is process simulation or discrete event simulation, and then there is Monte Carlo simulation. In discrete event or process simulation, you simulate the entire process of a particular decision making scenario. Like, for example, if you have inventories, you have demand, and the demand comes in, you have production, you schedule production, and the production process go through several steps, and you model each of those steps, how much time it will take for each production step to be completed, and then you take it into stock and you have demands appearing and you remove products from stock, and you simulate every step of the way. Okay, and that could be complex, and there are some really nice software packages available with which you can model that kind of simulation model. Or Monte Carlo simulation is where you only look at the outcome. For example, production, as we said, okay, how much production do you get in a day? Okay, so if that is going to be anywhere between 1,000 and 1,200 units, then you apply a probability model to it and then generate what will be the production in a given day, instead of going through the actual modeling of the production process itself, like the raw materials coming in and getting processed step by step by step into the final product. So not all decision problems can be modeled using Monte Carlo. You may need a process simulation which is much broader and it takes more time. Or if all you're interested in are outcomes which are not deterministic, then Monte Carlo simulation is very helpful. Okay, so how do you do the simulation? So you define the problem, and the problem has some variables that are not deterministic. Okay, how much money a customer will spend when they visit a retail web store or something, or how long will it take for the next breakdown to occur. If you're trying to model machine breakdown, what is the time between breakdowns? Okay, so that would be a non-deterministic value. Some probability distribution is associated with it, and we want to simulate that. So and then once you have the variables identified, so you set up a simulation model. Simulation model can be quite simple or complex depending upon the situation. So that modeling part is fairly straightforward. It is not very difficult. And then you run the simulation model. Well, and you have to set up scenarios for the simulation model. So for example, decision scenarios. So if you have a bank teller example, and how many tellers you want to have? You want to have 2 tellers, 3 tellers, 4 tellers, and or if you're talking about inventory models and how much inventory you want to hold, 200 units a day, 300 units a day, 400 units a day. So these are scenarios, possible courses of action that you want to test using the simulation model. And then you run the simulation experiment, okay, and here is where the power is. And if you have simulation modeling set up in a Excel model, then you can replicate the model for thousands of replications. So for example, if you're looking at daily operations of a bank and you want to consider different scenarios, and you can simulate the bank operation for 1000 days and then see what the outcomes over 1000 days will be. So it's a time compression, which is a major advantage, benefit of simulation. You'll be able to simulate 1000 days of operation in a matter of few seconds. So and then you look at the results and present the results, understand the results, and decide what course of action you want to take that makes best sense. Okay, so this is the process: define the problem, introduce variables, create the model, specify the values that you want to test the scenarios, conduct the simulation, and then examine the results and select the best course of action. So the advantage is relatively straightforward, flexible, and the advances in computer technology and software technology has made it possible. And there are a couple of Monte Carlo simulation packages that are available. One is called Palisades at Risk, and then there is one called Crystal Ball, and there may be others I'm not familiar with. These are Monte Carlo simulation software packages, and of course you don't even have to have these well-developed software packages to run Monte Carlo simulation, as we will see. So we're going to use Excel's built-in functions to set up Monte Carlo simulation models, and fairly straightforward. And you can run many what-if type of analysis in using the simulation model, and you can you don't have to change anything in the real world until you have already finished analyzing your simulation results. Yeah. And it enables study of various interacting components in a production, which is more so for process simulation rather than Monte Carlo simulation. Then enables time compression, which just mentioned, that you can simulate thousands of hours of operation in a matter of just few seconds. Enables the inclusion of real world complications. But there are some disadvantages. It can be expensive, especially if it is a complex model. You have to buy a software. I mean, these Monte Carlo simulation software packages can run thousands of dollars, and process simulation can run tens of thousands of dollars in terms of cost of software. And it does not generate optimal solutions like linear programming models, where you have deterministic values, and so you can get an optimal solution. Whereas here we have probabilistic models, and you simulate the actual reality. So you have to use trial and error approach to find the best possible solution. And also in a real life conditions, it is limited by the ingenuity of the managers and the modelers to come up with the real life scenarios that you can model using the simulation model. So each model is unique in the sense that you're modeling for your particular situation. It is not generalizable. Okay, so here are some of the examples that I already mentioned: inventory demand, lead time, time between breakdowns, service times, and inventory levels, how much stock you need to maintain, and things like that. Okay, there are 5 steps in Monte Carlo modeling. Establishing a probability distribution for important input variables. So we'll be looking at that in a concrete example. And then converting that probability distribution into something with which you can generate or simulate events. Okay. So for that you build a cumulative probability distribution, and then establishing random variables, random number ranges for each possible outcome, generating random numbers, and based on the random numbers we generate, you simulate a series of trials. Okay, so let's look at an example next.